Welcome back, guys. In this lecture, I'm going to discuss question number 31 to question number 35 from the GRE subject test mathematics practice book. So let us start from question number 31. It says that 4 cubes, each with faces numbered 1 to 6, to be rolled. When each cube is rolled, each number is equally likely to appear on its top face. What is the probability that at least 2 of the cubes will have the same number appear on their top face? So when we are rolling 4 dice or 4 cubes, we have to look for what is the top number, and we have to tell what is the probability that at least 2 of those top numbers are same. At least 2 are same, it means there is at least a pair which is same. So we have to find the probability of at least 2 same, or at least there exists one pair. We have to find this probability by using complement law of probability that says that P of A is same as 1 minus P of A complement. We have that this probability is equal to 1 minus probability of no pair. So 1 minus, I have to find out the probability that no pair exists, and this is going to be my answer. We can do it directly as well, but it's going to be a bit tedious and it will take a great amount of time. So let us do in this way. So we have basically 4 cubes. So let me draw the cubes. This is, let's say, first cube. And this is second cube. And this is third cube. And this is fourth cube. We have to look at their top face. So it would be 1 minus, what is the number on the top face? On the first cube, there can be any number, 1, 2, 3, 4, 5, 6, any number. So out of 6, because there are 6 faces in total, I have 6 ways, like there can be any number on the first cube. Let's say the number is 2, let's say. And multiplied by, on the second, I can have any number but not 2, because if there is 2, then it is going to be a pair, a same pair, which is repetition. So here can be any number. So I have total 5 ways out of 6. And like here, there is number 3. Now on the third one, there can be any number except 2 and except 3. It means now I have 4 choices because 2 choices are gone. 4 out of 6. And let's say the number here appeared is 6. Now on the third one, I don't want 2, I don't want 3, I don't want 6. I want any number which is not among these. So I have total 3 ways to assign those numbers. So it is 3 out of 6. So this is my probability and this is my answer. We just need to simplify and we are done. So how is simplification done? I can just cancel out these 2 numbers. I can apply table twice and table of 2 on both. Table of 2 again 3 times. Now I'm left with 1 minus 5 divided by 18, and taking LCM 18, my answer is 13 divided by 18, which is option B. That's it. So the correct option is, you can see correct option is B. So this question seems to be like really tough if you go directly, but if you apply complement law, which is this, then it makes your life easy. Okay, let's go ahead. This is really simple question. Most of the people who are doing basic mathematics of undergrad can do this question really in a very short amount of time. So which of the following sets of complex numbers is not a group under multiplication? So we have to show that which one of these following is not a group. So you know very well, for a group, we have to check certain properties, its closure, associative, and identity element, and we have to check the inverses. But if you are checking not a group, so you should basically start from backwards. You have to check inverses first. So if any of these does not involve inverse, you're good to go. So then it's not a group. You know very well from group theory that the set of real numbers or the set of complex numbers is not a group under multiplication. But if I just take out 0, then it's a group under, let's say, under ordinary multiplication is a group. So why we are just taking out 0? Because 0 does not have inverse with respect to multiplication. So we have to look for this thing. So when you look at the first example or the first option, which says that the numbers of this form a plus bi, so a plus bi is some sort of a number which is in complex notation form in I form, where a and b are positive rational numbers. So a and b are positive rational numbers. This is not a group because you have to check the properties that, okay, why it does not satisfy the property, and rest of these all are groups. You can check in all of these what is the inverse of a plus bi. So from the basic complex analysis, the inverse of a plus bi is a over a square plus b square minus b over a square plus b square I. Now the problem is this: a square plus b square. So a square plus b square, in the first option, it says that it is 1. Okay, if it is 1, then you're good to go. The inverse of a plus bi, inverse is a minus bi, because a square plus b square is 1 in option C. In option D, it is 1. In option E, it is 1. And this is set of real numbers, rational numbers, and integers. You're good to go in all these cases, because the thing that creates problem is the denominator. But if the denominator is 0, is non-zero, or it is explicitly a number, fixed number, let's say 1, then there is no issue. So there's no any instruction like that given in very first example. So it's not a what we call complex number. Sorry, it's not a group. There is another problem which you can see is in the inverse we have negative b. So if b is a rational number, if b is a positive rational number, so negative b is a negative rational number. So if b is positive, then negative b is negative rational number, which does not belong to the same group, to the same set that we have. Hence, it is not a group. So I said you already that when you are supposed to check that which one is not a group, you start from the first property satisfied, second property satisfied, third property satisfied, then you come to the fourth. So it takes a lot of time. So you directly start from the fourth, check fourth property is satisfied by which of those. So fourth property is satisfied by all of these except the first one. Now you might be wondering that, okay, why the set of integers is a group under multiplication? But it is set of integers which are integers in a plus bi form. And I told you what is the inverse of that. The inverse is going to be simply a minus bi. So if a is an integer, b is an integer, so the inverse of a plus bi in this case is a minus bi. Again, a is an integer and minus b is also an integer, because if you know that b is an integer, then minus b is also an integer, because integers involves all the positives and negatives, including 0. So there's no issue. So the correct option is A. Okay. Let us move ahead with a very simple question. So this simply involves some sort of study of differentials. It says that, okay, we have a spherical tank of radius 5 meters. Spherical tank is a tank which is in some sort of spherical form. So let me just draw it. So this is let's say let's say your spherical tank, and it has radius of 5 meters. It means from the center the distance is 5 meters, contains water that is slowly draining out. So it contains water up to some level that slowly drains out, and the maximum depth of the water in the tank is 2 meters. So the maximum depth is, let's say the water is up to here. So this is water, and above that there is no water, and the height of the water or the depth of the water is 2 meters, and depth is decreasing 1/3 per second. What is the rate of the decrease of volume of the water in cubic per second at that instant? So we'll simply apply the study of differentials. We know very well that volume of a sphere is 4/3 pi r cube. This is the formula for the volume of sphere. I will simply apply the differential on both sides. So this becomes dv. I have to differentiate the right hand side with respect to the radius. 4/3 pi remains same. This square becomes dr square. 3r square dr, and dr is the differential for r. And you can see these are cancelled. dv is 4 pi r square dr. Now I just need to substitute the values. So 4 pi, this is r. What is the radius? What is the height over there? Not the radius, it's 2. Is it 2? Yes, it's 2. And the depth is decreasing by 1/3. Depth is decreasing, it means there is fixed radius, and that radius is decreasing. So that's 1/3. So you just need to simply, that will give you the rate of change of volume, or in other words, that will give you dV. So what is dV? So 4, this is 16 pi by 3. So this is our answer. Do we have? Yeah, it's option A, 16 pi by 3. So this was question number 33, which is really simple if you apply simply the differentials. Let us move towards question number 34. Let me do it over here on the top. So I have a function which is, function which is given by this, and this is defined for every real number except 0, because at 0 this is not defined. 1/0 is not defined. This notation shows the composition of f and f. I have to find out this composition. F composed with itself 100 times. So first of all, let me find out what is f to the 2, or in other words, f composed with itself twice. So this is f of x. So what is my f of x? 1 minus 1 over 1 minus 1 over x, but at the place of x, I have to substitute f of x. Then this becomes 1 minus 1 over, now what's the value of f of x again? 1 over 1 minus 1 over x. Now I need to simplify this. That's it. Then I'm done. So 1 minus, the LCM is x, and this becomes x minus 1. I can take this x in the numerator. So this becomes 1 minus 1 upon x minus 1, not 1, this is x. Taking LCM again, this becomes x minus 1 minus x minus x cancel, minus 1 over x minus 1. 1 minus 1 over x. So x minus 1 over x. X goes in top. LCM is x minus 1. Okay. LCM is x minus 1, x minus 1 minus x. Minus 1 over x minus 1. I can write 1 over 1 minus x. So 1 over 1 minus x. What does it become? Okay. So I have to apply this 100 times. Then I have to check that, okay, what is going to be the answer? I have to apply this 100 times. Okay. So this 2 times seems to be D. And can I get something else from this one? 1 over 1 minus x. Is there any mistake in this one? Okay, now I'm applying, I'm doing f composed with itself 4 times, that is f composed with itself 2 times, composed with f composed with itself 2 times. So I'm doing it 2 times. So 1 over 1 minus, now at the place of this x, I will substitute the composed form of this, which is 1 over 1 minus x. So I'm writing this with black now for this space. So LCM would be 1 minus x, which becomes the numerator, and 1 minus x minus 1. So this is cancelled. Now you can divide 1 upon minus x over minus x. This becomes 1, and I have this minus 1 over x. Yeah, so it is the same answer as you can see. So if I apply f 4 times, it gives me same answer again. So let me tell you, if I'm going to compose f with itself, hundred times, so 100 is divisible by 4, you know very well. So these 4 give me f again, and these 4 give me f again, and all of in between give me f again. So I will get these f's again and again, and my final answer would be f again. So which is option A. At that you can check easily. And if there is only any issue in this one, then let me know in the comments. I will just make it correct, and I will upload maybe another video for this. But I think this is going to be the option. Yeah, so these f's will be 25, and out of 1, and remaining would be again 24, and 24 divided by 4, there would be 6, and yeah, I think it would be the answer, but we'll check. You can further check by yourself. That's true or not. Okay, let us discuss the last question for today. I have a sequence which is defined by this. I have to find out what is going to be the limit. So sometimes like limit can be found by simply converting the limit in the form of integrals. That works when n goes to infinity. I can simply convert this in the form of integrals. So I'm going to write this integral from 1 to n and limit n goes to infinity, n over n square plus k square. Since the index for summation is k, so I will write this integral in the form of k. So I simply wrote this thing, and limit is from 1 to n, where limit n goes to infinity, and integral with respect to k, because the index here, the summation index is k. Okay. So just integrate this thing, seemingly like you have to apply some sort of transformations to cancel this n. So what am I doing? I'm substituting k is equal to nx. So dk would be n dx. And limit n goes to infinity. What are the limit changes? So if k is equal to 1 implies x is equal to 1 over n. You can substitute just here k is equal to 1 and you will get the value of x to be 1 over n. And when you will substitute k is equal to n, it implies x is equal to 1. And this is n over n square. K square becomes n square plus x square, and dk is n dx. Now, n square, I can take n square common. This becomes 1 plus x square dx, and this is 1 over n to 1. So this is now limit n goes to infinity, 1 over n to 1. I can simply cancel these. Now I have 1 over 1 plus x square dx. And you know very well this is some sort of elementary integral, and whose integral is tan inverse x from 1 over n to 1, which is equal to limit n goes to infinity. Just substitute the value tan inverse 1 minus tan inverse 1 over n. Now you can apply the limit. Tan inverse 1 minus tan inverse 1 over n. When n goes to infinity, it becomes 0. Now just if you know the values of these, then you are done. Tan inverse 1 is very famous. Let me write these things here, which is pi by 4. And tan inverse 0 is 0. So my answer is pi by 4. So pi by 4. So it's going to be option B, pi by 4. So this was question number 35. And in the next lecture, I will discuss question number 36 to 40. Till then, see you and goodbye.